Hello, this is a walkthrough for the WJEC Unit 2 Higher Tier paper from June 2023. Calculator is allowed and you are allowed 1 hour and 45 minutes. In order to benefit the most from this walkthrough, I would advise that you work through the paper in advance of listening to the recording, or alternatively, once you get to a question, just press pause, have a go, and then play the recording. Just pause here. Always worth just having a quick look at the formulas that you'll get. So we've got the area of the trapezium, volume of a prism, volume of a sphere, formulas to do with the cone, and then non-right angled trigonometry, quadratic equation, and your AER formula. Question 1. We have to solve this equation. So step number 1 is we're going to multiply out this bracket. So we're going to have 7 plus 5x minus 10 is equal to 3x plus 8. Okay. I want to tidy up these numbers on this side. I start to rearrange. So it's going to give me minus 3, 3x plus 8. I'm going to collect my x's together. So subtract 3x is going to give me 2x minus 3 is equal to 8. Add 3 to both sides. And then divide by 2. Which is going to give me x is 11 over 2, or we can change that to the decimal. This is 5.5. Either form is fine. B. Make f the subject of the formula. H is 13 minus 2f. When I'm rearranging formulas, I don't really like to work with a negative. So first step, I'm going to add 2f. Both sides. So h plus 2f is equal to 13. Then if I want to make f the subject, I want to get f on its own over here. So I'm going to subtract h on both sides. And then finally divide by 2. You may have arranged it in a different way. So if you didn't start by adding 2f, you may well have f equals h minus 13 over negative 2, which is also a correct answer. You can just see that all the signs are just opposite. Let's see, factorize 15x minus 35y. So factorize, we're going to put the brackets in. Let's see what's common to both these terms. So just 5 in this case, got no common letters. And inside my bracket, I'm going to have 3x minus 7y. Question 2. A large number of prize tokens are placed in a box. The tokens are identical in shape and size. Gold, silver, bronze, or no prize is written on each token. One token is chosen at random from the box. The table below shows the probability of choosing a gold prize token and the probability of choosing a silver prize token. Part A tells us there are 3 times as many no prize tokens in the box as there are bronze prize tokens, and we need to complete the table. So we know that total probability adds up to 1. Let's have a look what we've got here. So let's add these two. So 0.02 plus 0.18 is going to give us 0.2. So what have we got left for the remaining two? So 1 subtract 0.2, that's going to give us 0.8. So we've got 3 times as many no prize. So let's think of this as a ratio. So we've got 3 times as many no prize as we have winners. So if I add my total parts, I've got 1 plus 3 gives me 4 parts. I divide with 0.8 into 4 parts, that's going to give me 0.2. So bronze would be 0.2 and no prize, it's going to be 3 lots of 0.2, isn't it? Gives me 0.6. Always good to check at this stage that it adds up to what? There are 15 gold prize tokens in the box. We need to work out how many silver prize tokens are in the box. So gold is going to be 0.02. It might be easier to think about this as a percentage. So 2% is going to be 15 gold. And we want to work out how many silver. So that's going to be 0.18 or 18%. So hopefully we can spot the link here. This is going to be multiplied by 9. So it's going to be 9 times 15, which will be 135 tokens. You may have also worked backwards with this probability. So if you take 15 divided by 0.02, it will give you a total of 750 tokens, which you can then multiply by 0.18. Will also give you the answer 135. Question 3. Solution to the equation x cubed minus 8x plus 3 equals 0 lies between 2 and 3. We need to use the method of trial and improvement to find the solution correct to 1 decimal place. So let's draw out our table. Always leave lots of space for the middle column. So in our first column, we're going to think about the x value. Then we're going to work out x cubed minus 8x plus 3. And then we want to have a think about whether it's too high or too low. So the most obvious place to start is in the middle of 2 and 3, so 2.5. Let's substitute that into calculator, into the equation, and then we'll pop it into the calculator. Okay, so 2.5. The cubed button, we can either do this one and pop a little 3 into the box, or you can do shift and x squared. Either way works. So minus 8 times 2.5 plus 3. Let's change that to a decimal. It's going to give us minus 1.375. Okay. We're aiming for 0, so that's going to be too low. So what we want to do is, let's have a look at 2.6. So don't type the whole thing in again, just back. We can just replace this bit here with the 6. Which is going to give me negative 0.224. Let's pop this in. Which is also too low. Okay, so let's try 2.7. in the calculator, that would give you an answer of 1.083. Just redraw that one. Okay, this one is too high. We're narrowing in. So what we need to think about now is our solution going to be closer to 2.6 or to 2.7? Okay, so 2.6 too low, isn't it? 2.7 too high. Let's work out 2.65. So back to the calculator, and that should give you an answer of 0.409 and so on, which is too high. So we can see here that our solution, this is where the signs of change, should be somewhere here between 2.6 and 2.65. So it's going to be closer to 2.6. So x is equal to 2.6 to 1 decimal place. Or A, evaluates this. Give your answer correct to two significant figures. Okay, so let's go back to the calculator and let's pop. So first of all, you want to press the fraction key. Let's type it in exactly as we can see it on the page. So shift and this square root will give you the cube root, 154. And then down takes us to the denominator, 7.9 minus 3.36. And that's going to give me an answer of 1.155. So let's write that down and then we'll round it. So 1.155 and so on. So two significant figures. Just be a little bit careful here. It's different to two decimal places. So this is my first significant figure. Second one, that's the cutoff. This 5 here means that it's going to round to 1.2. Two significant figures. Part B, calculate the reciprocal of 23. So reciprocal just means 1 over. So reciprocal of 23, 1 over 23. Pop that into the calculator, change it to a decimal, and you should get the answer 0.043. Part C, circle the correct answer for each of the following. The lowest common multiple of 4 and 6 is. So let's think about multiples of 4. So it's essentially the 4 times table. Multiples of 6, we've got 6. In fact, there we go. The first number that we come to is going to be 12. The highest common factor of 10 and 15. So let's think about factors of 10 and factors of 15. So 10, we're going to have 1, 3. That's for 15. 1, 2, 5, and 10. And 15 is going to be 1, 3, 5, and 15. Okay, so let's have a look. What's the highest number that's included in both these lists? So it's going to be 5. Question 5. Solve the following simultaneous equations using an algebraic, not graphical method. You must show all your working. So what we're going to do, let's have a look at these equations. We need to, first of all, check that whether we've got the coefficient of the x or the y that's the same. Well, we haven't in this case, so we're going to have to make them the same. So I'm going to choose to make the y's the same so that I can add them together. You may well have done the x's. That's absolutely fine. You should still come to the same solutions. So this first equation, I'm going to multiply by 2. Second equation, I'm going to multiply by 3. Okay, so that should give me the equation 4x, that's 6y, is equal to 32.8. And the other one should give us 9x minus 6y is equal to 23.1. Now we have the y coefficients are the same. The signs are different here, so we're going to add them together to eliminate the y terms, which is going to give us 13x is equal to 55.9. Divided by 13, it's going to give me x is equal to 4.3. We need to work out y, so substitute it back. Either equation is fine, but I'm going to use the first one. So 2 times 4.3 plus 3y is going to be equal to 16.4. That's going to be 8.6. The 8.6, that's going to give me 3y is equal to 7.8. Divide by 3. And y is equal to 2.6. So it's good practice just to substitute it into the other equation, see if the solutions work. So let's do that. So 3 times 4.3 minus 2 times 2.6. Let's check that. And that gives us 7.7. So we can be confident our answers are correct. Question 6. In the diagram below, AD is a straight line. BAC equals 90 degrees. So BAC, that's this angle here. BDE, 90 degrees, and CBE, 90 degrees. AC, 7.7, BC, 11.3, and BD, 13.1. So that's just the information we can see on the diagram. It's always worth reading through just to see if there is any other information included. Asked to calculate the value of x. Okay. So we've got a right angle triangle. We know 2 sides and we want to work out the angle. So we're going to use SOHCAHTOA. Let's have a think about, so in relation to this angle, we've got the opposite side and we've got the longest side opposite the right angle. So that one's going to be the opposite and the hypotenuse. That's going to be sine. So I know that sine of x is going to be equal to the opposite over the hypotenuse. That's going to be 7.7 divided by 11.3. And in order to work out x, we need to do inverse sine. 7.7 over 11.3. You might want to change that to a decimal first of all, if you feel more comfortable doing that. But we can put this all together in the calculator. So shift sine, and then type it in as a fraction, and that's going to give me an angle of 42.95 degrees. Part B. It says, hence find the length DE. So we have got some space here, but I'm going to go back up here so we can look at the diagram as well. Very tricky to do it without having the diagram. Okay, so let's work out DE. So we know one side here, we want to know another side. We're going to need some more information, aren't we? So we're going to have to work out this angle here. So we've got angles in a straight line, add up to 180. Let's subtract 90 and this angle that we've just worked out here. So that's going to give us answer of 47.05. Okay, so DE, let's call this, we've used X, so let's call this Y. So I'm just going to change to a different colour of pen, just because there's quite a lot of information on here already. So let's do this one in red. So let's think about which sides we've got. So this is the angle, this is going to be the opposite side again, and then we've got the adjacent. So this time we're going to use tan. And what we've got is, so tan of my angle, 47.05. That's going to be equal to the opposite, which is y divided by 13.1. Okay. If I rearrange here, I'm going to multiply by 13.1 to work out y. So I'm going to have y is equal to 13.1 times tan 47.05. And that's going to give me an answer of 14.07 to 2 decimal places. In centimetres. It was good to include the units wherever they're provided. Question 7. A number is decreased by 5% of its value. This is done 4 times in total. Each time the value decreases by 5%. Circle the multiplier that you would use to find the value after the 4 decreases. Okay, so we're going to start with 100%. We're going to decrease it by 5%. That leaves us with 95%. As a decimal, that is going to be 0.95. And we're going to do it 4 times. So multiplying by 0.954 times is going to give us this multiplier. Part B. The number has been decreased by 17% to give us an answer of 3,569. What was the original number? So we started with 100%. We've subtracted 17%. That's going to leave us with 83% remaining. Okay, so these type of questions called reverse percentages. So we're going to work in reverse of our usual process. So we know our key information is that 83% of this number is equal to 3,569. Okay, so we're going to scale this down to 1% and then up to 100%. Okay, so to go from 83 down to 1, we're going to divide by 83. So 3,569 divided by 83, that's going to give me 43. And then to scale it up to 100%, I'm going to multiply by 100, which is going to give me 4,300. There is an alternate method you may well have used. So if we are using decimal multipliers, we could also divide by 0.83. So that would also take us to the solution. So either method will work. Question 8. The diagram below shows a semicircle with radius r drawn inside a trapezium. The area of the semicircle is 77 centimeters squared. The semicircle touches the line AB, so we can see here that's also going to be the radius, and AB is 22. So calculate the area of the trapezium ABCD. Okay, so on our formula sheet, we're told that the area of a trapezium is half A plus B times H. So A and B are the two parallel sides, and H is the parallel height between them. Okay, so let's have a think about on this diagram. We've got 22 for the base. This is going to be 2r for the top, and the height is going to be r. So what we really need to do in order to go any further is to work out what is the value of r. So we're given some information about the circle. So the area of the semicircle is 77 centimeters squared. So area of a circle, pi r squared. It's a semicircle, so we'd need to divide that by 2, and that's equal to 7. Okay. So let's get rid of this fraction. Let's multiply by 2. And what we need, pi r squared here is going to be equal to 154. R squared, we need to divide by pi here. And then square root. So r is going to be the square root of 154 divided by pi, which is going to give us 7.00. So I'm just going to use 7 for the remainder of the question. Okay, so now let's have a little bit of a think about this trapezium. So I've got my lengths here. So 2 lots of the radius along the top, that's going to be 14. My base is 22. The height between them is going to be the radius, so that's 7. Let's pop those numbers into the equation. And that's going to give me an answer of 126, and it's in centimetres squared, as it's an area. Question 9. Enlarge the given triangle by a scale factor of -2 using point A as the centre of enlargement. Okay, so scale factor -2 is going to take us, rather than taking us further away, it's going to take us in the opposite direction from the centre. Because it's factor 2, it's going to be, all my lengths are going to be doubled. So we've got here is 4 and this is 2. So rather than going 4 to the left, I'm going to go 8 to the right. So 2, 4, 6, 8. And instead of going 2 up, I'm going to go 4 down. Okay, and then I just need to join those 2 points. Obviously, you want to do this with the ruler in your exam. Question 10. ABCDE is a regular pentagon with sides 11 centimeters. CDE is a sector of a circle with center D and radius 11. The two shapes are joined together as shown below. In this part of the question, you will be assessed on the quality of your organisation, communication and accuracy in writing. Calculate the length of the arc CE as shown in the diagram. You must show all your workings. So what we have here is the arc CE. Okay, that's obviously a fraction of the circumference of the circle, isn't it? So just a little reminder that the circumference of the circle, if we're given the radius, is going to be 2 pi r. If we then need to work out a fraction of it, we could do with really working out what this angle is. So the arc is going to be, if we call this angle theta, it's going to be theta divided by 360, so the fraction of the circle times r. So let's work out what is this angle. We're going to have to start with calculating this angle here. Okay, so we've got a regular pentagon. So if we want to work out the interior angle, so for an n-sided polygon, we can work out if we subtract 2 from the number of sides, multiply it by 180, that gives us the total interior angles. So 3 times 180 is going to give us 40. If we then divide that by 5, so 5 angles, it's going to give us 108 degrees. So this angle here, 108 degrees. To work this one out, we're just going to do 360, take away that, which is going to give us 252. Okay, so let's go back to the formula, substitute our values in here. So it's going to be equal to 252 over 360 times 2 times 11, which is the radius. 36 there. Which is going to give us 48.4 centimetres. In a shape similar to the one shown on the previous page, the regular pentagon has sides of length 671 centimetres. Okay, so we've got pentagon with sides 671. So the total area of the new shape is equal to some number times the total area of the original shape. Okay, so our original shape over the page had sides of 11 centimetres. So let's work out what's the scale factor going to be there. So let's take 671 divided by 11. What's that going to give us? Is going to be equal to 61. So my length scale factor is 61. What we want to work out though is the area scale factor. So area scale factor is just going to be 61 squared. If we wanted the volume scale factor, 61 cubed. Okay, 61 squared is going to be 3,721. So it's just going to be 3,721 times the total area of your original shape. Question 11. Make x the subject of the formula ax squared plus x squared is equal to b. Okay, so if we're going to make x the subject, we want to get it on its own. The first step that we need to do is factorize. Okay, so we've got x squared as common to both of these first terms. If we factorize, that leaves us with a plus 1, and that's equal to b. Okay. Then what I want to do is divide by a plus 1. So we have x squared equals b over a plus 1. And then we need to square root both sides. Really important that whenever we square root, we have a positive and a negative answer. So it's going to be plus or minus the square root of b over a plus 1. Question 12. Part A. Factorize 8x squared minus 18. Okay, so we can see here 2 is a factor of both of these terms. So give us 4x squared minus 9. Both these are square term. This is actually what we would call the difference of 2 squares. So what we would do to put this into 2 brackets, we're going to square root the first term. So square root of this would be 2x. So 2x times 2x gives us 4x squared. If we square root 9, we're going to get 3. Okay, the difference of 2 squares, one of my brackets is going to be plus, one of my brackets is going to be minus, because that will cancel out those middle 6x terms. You might want to just multiply that out just to check. Okay, so that's factorized. Part B asks us to hence solve this equation equal to 0. Okay, so let's take what we've just done. So we know that that's equal to 2x plus 3, x minus 3 times 2, and it's equal to 0. Okay, so in order to solve this, is a bit more tricky than we might be used to. We're going to, first of all, divide by 2, so we can get rid of that 2 at the beginning, so 2x plus 3. 2x minus 3 is equal to 0. And in order for this to be equal to 0, we're either going to have this first bracket, so 2x plus 3 is equal to 0, or 2x minus 3 is equal to 0. So if we solve both of these individually, we should find the values. So 2x is equal to minus 3, x is equal to minus 3 over 2. You can write it as a decimal if you want, doesn't matter. Or 2x is equal to 3, and x is equal to 3 over 2, or 1.5. Would be good just to check your answers. So if you pop those back into this original equation, each of these x values, you should find that they're both equal to 0 if you've solved it correctly. It's always good to check your answers wherever you can. Okay, so it says, hence sketch the graph of y equals 8x squared minus 18 on the axes below. Mark clearly the coordinates of any point where this graph crosses an axis. Okay, so this is a quadratic. Quadratic is going to be, it's positive as well. So it's going to be this kind of smiley face shape. If it was a negative x squared, it would just be the sad face, negative quadratic. Okay, what we've just worked out, so in the previous part of the question, we've worked out where y is equal to 0, the values of x. So basically, my values of x when y is equal to 0 is going to be 1.5 or negative 1.5. Okay, so that's the points where it's going to cross the x-axis. We need to think about where it's going to cross the y-axis. And that's going to be when x is equal to 0. I'm going to leave myself space there to draw my graph. And my original equation is 8x squared minus 18. If I sub 0 in, that's just going to be 8 times 0 minus 18, which is obviously going to give us negative 18 is the y-intercept. So let's draw a bit of a top tip. I would draw the graph and then label the points of intersection. A bit easier to draw a smooth curve if you're not actually aiming for any particular points. So we want roughly the same distance either side here. So we've got 1.5, negative 1.5 here, and then this intercept here is going to be negative 18. Question 13. Catherine has 3 spinners as shown below. She spins each spinner once. Calculate the probability that all 3 spinners land on prime numbers. Okay, so my prime numbers 2, 3, 5. We don't need to go any further, do we? So for this first spinner, my probability of it landing on a prime number is going to be 2 out of 4. Second spinner is going to be 3 out of 5. And for this third spinner, it's going to be 3 out of 6. Okay, so we want all 3 spinners to land on prime numbers. So this spinner and this spinner. So wherever you're saying and in a probability statement, you want to multiply the probabilities. So and the third spinner. Let's pop this directly into your calculator. And that's going to give you a simplified answer of 3 over 20. The numbers that the 3 spinners land on are added together. Calculate the probability that the total is greater than 4. Okay, so just looking at these spinners, we've got numbers obviously up to 4, 5 and 6 on them. So there's going to be a lot of options that are going to give us scores greater than 4. Okay. It would be a lot more efficient in this case for us to work out the probability that it's less than or equal to 4. And then we know that total probability adds up to 1. So if we can work this out, which we can a lot more efficiently, a lot more easily, we can subtract that then from 1. Okay, so let's have a little think about what options are there where it's going to add up to 4 or less. So we have the probability of getting 1 on each spinner, probability of 2 on the first spinner, then 1 on the other 2 spinners, and then we've got the probability of 1, 2, and then 1, and finally the probability of 1, 1, and 2. So it's really important to think about the different orders they could happen in. So let's see. So this is going to be 1 out of 4, isn't it? Times 1 out of 5 times 1 out of 6. This is 1, 2. So in fact, these are all going to be the same probabilities here. So 1 over 4 times 1 over 5 times 1 over 6, and again 4 times 1 over 5 times 1 over 6. So in order to work it out, could be a bit more efficient, we're going to do 1 minus, and we could do 4 lots of this 1 over 4 times 1 over 5 times 1 over 6. Okay, let's put that into the calculator. So it's going to give me 1 minus 1 over 30. It's going to give me 29 over 30. Or any equivalent fraction, so you may well have left that over 120. Question 14. The cube has a volume of 10,648 centimetres squared. Cubed rather, sorry, it's a volume. And we've got to calculate the length of the internal diagonal AB. Okay. So what we could do with working out first is the length of a side. So it's going to be a cube. They're all going to be the same, aren't they? So what we need to do first of all, let's work out the cube root of this. Work out the side length. That's going to give us 22 centimetres. So let's label these. Okay, and we want this internal diagonal here. We could do with just working out an interim step. So if we call this point C, we've got this triangle here. C. Okay, and this is what we want to work out here, this length AB. Okay, so in order to work out CB, we have another right angled triangle here where we've got the lengths 22 and 22. Okay, so if we want to work out BC, it's going to be 22 squared plus 22 squared. So Pythagoras. And that's going to give us 968. So BC is going to be the square root of 968. Which is going to give me 22 root 2. Okay. I'm going to leave that as 22 root 2 and just use that in my next calculation. And then I've got 22 for this AC. So let's do another step. Squared is going to be equal to 22 squared less 22 root 2 squared. Which is going to be equal to 1,452. So square root it. Obviously x is going to be positive, isn't it? It's a length, so we only need to take the positive square root this time. So 1,452 square root is going to be 38.1, and it's length, isn't it? So it's going to be centimetres to 1 decimal place. Question 15. Use the quadratic formula to solve the equation 1 over x minus 2 plus 1 over 3x minus 7 is equal to 1. Okay, so obviously in order to use the quadratic formula, we're going to have it in the form ax squared first plus bx plus c. Okay, so let's just rewrite it here. Okay, so what I want to do first of all is get rid of these denominators. That should be equal to 0 there. So I'm going to multiply the whole thing by x minus 2, 3x minus 7, which is going to give me, that's going to cancel out the x minus 2 here. So I'm going to get 3x minus 7 plus. So my 3x minus 7 is going to cancel here. So I'm going to get x minus 2, and that's going to be equal to x minus 2 times 3x minus 7. Okay, so I could do simplifying this a little bit. I'm going to collect together my terms on this side. I get 4x minus 9. Oh, here I'll just multiply out this side too. So 3x squared minus 7x minus 6x plus 14. Okay, so I'll just collect together the right-hand side. So minus 7 minus 6, that's going to give me minus 13x plus 14. And then I've got my x squared over here. I want to leave my x squared positive, so I'm going to take everything over to the right-hand side. If you don't feel comfortable working on the right-hand side, you can always just rewrite this the other way round with this 3x squared on the left-hand side to continue. So it's going to be 3x squared. I'm going to subtract 4x, so it's going to give me minus 17x, and I'm going to add 9, so it's going to give me plus 23. Okay, so now that is in the form that I want to use. Okay, so let's have a little think. What is A? So A is going to be this 3, isn't it, in front of the x squared. B is going to be negative 17, and C is 23. Okay, so let's be nice and organized. Okay, and then we need the quadratic formula. So on your formula sheet at the front, you've got your quadratic formula, so let's write it out. That's minus b, so minus the square root of b squared minus 4ac all over 2a. So let's substitute these numbers in. So minus b minus a minus is going to give us positive 17 plus or minus the square root. So b squared is going to be negative 17 squared. Just be careful to use your brackets here. It's really important. Minus 4 and 3 times 23, all divided by 2 times 3. Okay, so if you pop that into your calculator, what I would do is, if you do the positive root first, and then just back, change that plus to a minus to find your second solution. Okay, and that should give you two values. So go down here. X is going to be equal to, so it says to 2 decimal places, so it's going to be equal to 3.43, or x equals 2.23. Question 16, so there's a final question on the paper. So in triangle ABC, shown below, AB is 13, BC is 11. D is a point on AC where BD equals 7 and DC equals centimeters. And we want to calculate the size of BAD. So BAD is this angle here. Okay. So we've got two triangles here. It's the last question on the paper. It's an indication, 6 marks, that we're probably going to have to do more than one step. Okay. This is not a right angle triangle. Okay, so we're not able to use Pythagoras. We're not able to use SOHCAHTOA. We're going to have to use our non-right angle trig. So we can use the sine rule or the cosine rule when the triangle is not right angled. Okay, so I could see if I can work out this angle here, then I can use the sine rule to work out this. Okay, so what I'm going to have to do is I'm going to have to start with the right-hand side here, and what I'm going to do is work out this angle here. Okay, so I'm going to call this angle, in fact, let's just have a little think about which rule we're going to use before we decide what to call it. So we've got 3 sides and we want to work out the angle here, so it's going to be the cosine rule. I would recommend, so we're going to use the cosine rule to work out the angle. I would recommend that you learn the rearranged formula for the cosine rule. So you've got cos A is equal to B squared plus C squared minus A squared over 2BC. Okay, so A, I'm going to label these just to fit with this rather than changing all the letters. So we'll just use the form that we're familiar with. Okay, so if we call this A, the side opposite, really important, that is little a. Okay. This 7 and this 5 doesn't matter which is B and which is C, so they've got the same role in this. Okay, so let's pop the values in here. So we've got 7 squared plus 5 squared minus 11 squared divided by 2 times 5 times 7. So if I put this in the calculator, it's going to give me, it's 47 over 70. And then I want to do inverse cos, so cos minus 1 with ants. And that's going to give me an angle of 132.18 degrees. Okay, so I know that this angle here, 132.18 degrees. Okay, so let's change colour because we're going over to the other side. So we've got angles in a straight line here. So this other angle here, so 180 subtract my angle, 180 is going to give me 47.82. Okay, so I've got the sine rule for this one because we've got pairs. We've got these two sides that make a pair, these two sides here that make a pair. Okay, so whatever I want to work out, I'm going to start with that on the top of my fraction. So the sine rule will work either way. So in this case, I'm going to have sine A over A equals sine B over B. Okay, so this is A. This is now going to be little a. So sine A over 7. And then I've got my other pair here. So we've got, this is going to be B, isn't it, and small b. So it's going to equal sine of 47 and 82 divided by 13. So in order to rearrange, I'm going to have 7 times sine 47. I'm just going to get rid of this line because it's in the way of my workings now. I'm going to do over 13. I'm going to do inverse sine of this. I'm just going to put this all into my calculator in one, but if you'd prefer to work it through as the decimal, it's absolutely fine. We're going to get to the same answer. So let's work that out. And that's going to give us answer 23.531 decimal place. Okay, thank you for listening. Good luck with your exams.